Hello, very good evening, guys. Welcome to the faculty driven platform that is Resultant. Very good evening, all of you. How are you all? All right. So, today we're gonna discuss about a very interesting and important topic from the GATE examination perspective, that is the LPP, and in LPP we'll be talking about graphical. So in this video I will be discussing the entire basic understanding of LPP, right? And that too, how to solve the question. So I'll be taking one problem, and from that single problem we'll be able to understand the entire concept of linear programming problem through the graphical approach or graphical method. Okay, so I hope so everything is good and fine. Please do let me know in the comment section. Let me check. I think it's all good, right? 1 2 3 4 5 6. Okay, chaliye. Very good evening. Good evening. Let me check. All right. So, like yesterday, we had a discussion of the inventory models, right? So today we'll be extending our discussion to the next topic from the industrial engineering for GATE 2025, that is your linear programming problem. So first of all, let us understand what is the requirement of linear programming problem or LPP method. And by the name linear means we will be having the equations or the formulations will be of single power, because it's a linear equation. It won't be a square or cube. It won't be a quadratic equation. It will be a linear equation, right? So now question is why we are using LPP, which is basically a mathematical tool, and how we can use this mathematical tool in the different practical examples. So all this doubts, all the examples we will be covering in this short video of 20-25 minutes, I think. And before starting the session, I will request you, please do subscribe to all the please subscribe to this channel. The reason being because every time whenever we are bringing something new, you should be the first one that won't be skipping out. Okay, you will be notified first. So that is the reason I always insist you to try to subscribe to this very beautiful platform that is Resultant. Okay, chaliye. So now let's start with the discussion. So before starting, I again welcome you back to Resultant, where our entire mechanical and civil team, India's best mechanical civil team, will be present in this one single platform. And before starting, again I'm repeating, please do like, subscribe. I hope so everyone has done, and do share this video. Now if you have any doubt or difficulty, you can do connect with me on my Telegram channel, that is Mechanical by Suraj Gopi, and I'll be happy to help you out on all the subjects, but specifically I'll be dealing with the subject that you're seeing on the screen, right, starting from mechanics till standard quality and practices, that is for the ESE. Okay, chaliye. So yes, so everyone please do let me know what is the meaning of LPP and why we are using this LPP. LPP is basically is a very we can say is the best tool for optimizing any problem. Let us take an example. You want to go from A point to B point. Okay, and there are several pathways. We are having path 1, we are having path 2, we are having path 3. So we are having, let's say, 4 to 5 different pathways. So how to identify which pathway will be best suitable for us? By having some boundary condition, by having some limiting conditions. Okay, right? Let us suppose if you go by path 1, the expenditure will be very high. If you go by path 3, the expenditure will be very low, but the quality will be very bad. If you go with path 2, we'll be having some other alternatives. So definitely in every pathway, we are experiencing different, we can say, variables, different solutions. So among all the solutions present, how we can identify the best possible solution, that is basically we call it as a linear programming. Okay, so it is the simplest way of optimizing a problem where we are having more than 1 or 2, we are having a range of solutions. Let us say I'm having a solution between 1 to 100. So we'll be saying so only 100 solutions are there. No, we'll be having infinite. We can take 1, we can take 1.1, we can take 1.11, we can take 1.111. So in this way, from 1 to 100, even if I take 1 to 5 also, we are having infinite possible values. So among this infinite possible values, which will be giving us the best possible solution, that is your linear programming problem. Now the second doubt that you will be having, sir, okay, it's a mathematical tool which is we are using to optimize the solution, optimize the problem, right? So my question is, where we are using this in real life? Anyone? Can anyone who can help me out where we are actually using this in real life? The answer to this question is we are using in the best possible answer is supply chain and management. In supply chain, where we need to optimize the demand and supply, where we need to see which one will be the optimal route for transporting any good from one point to another point, there we are using this linear programming problem. And because it's a mathematical tool, so definitely that will be giving me the best possible results and in less time. We'll be doing some iterations, right? Like when in future, in next class, when we'll be discussing about the simplex method, there will be talking about iterations. So remember, iteration means step by step solutions of any problem, right? Okay, so if you are solving any question step by step, if you are solving any question step by step, and you are iterating again and again to get the best result, and if you're using a software, can you believe you'll be getting a best possible result? And that's the same thing we are doing over here. Okay, to solve any LPP problem, we are having two approaches. One is graphical, second is the simplex. So today's session will be purely based for the graphical approach, and we'll be talking about what are the limitation of using the graphical approach. Okay, fine. And then tomorrow we'll be talking about the simplex method. And simplex method, please make sure you are not skipping out the simplex, because students do have difficulty in simplex. And whatever we are discussing today, tomorrow the same thing will be discussed with a new method. That is the reason today's session and tomorrow's sessions both are interlinked with each other. Okay, chalo. We can formulate a real world problem into a mathematical model by using this method. What real problem, what real challenges that we are having? First one is a transportation problem, just I told you, right? So we can use the LPP method, okay, in the diet problem. Diet problem means you might have seen the nutritionists, okay, or dietitians, what they prefer. They try to give that you need to have this much of carb, you need to have this much of protein, this much of carbohydrates, okay, this much of fat is required. So basically what we are doing, we are having n number of food ingredients, and among that which best combination will be suiting your body, that particular problem we can solve by using this LPP. Nowadays we are having the software, just you need to fit the input, like this much of nutrient is required, this much of food is the list of foods which is the best possible diet for me according to my body mass index. Okay, so here we can say the constraints are, the restrictions are the specified nutritional requirements. Let us suppose your body mass index is very high, right? So definitely you need to cut down some specific nutrients, right? You need to add some specific nutrients. So basically based on that, we are trying to make a diet chart, and that particular diet chart we can use by the best possible diet chart that we can use by using this LPP method. Okay, and what is the objective function? The cost of food intake. Second type of example, real life example that we're using in manufacturing. In later on session, when we'll be having the practice sessions of LPP, there we might have seen that almost 80% of the question asked till date from this topic are from manufacturing problem. We'll be having the work hour, we'll be having the labor, we'll be having some material constraints, right? So based on that constraints, we need to optimize what will be the cost of production. Okay, the third, this is we can say a special case of LPP. You will be seeing a transportation problem, right, where we'll be using 5 different methods. We'll be having northwest corner rule, we're having the row minima, we're having the column minima, we're having the Vogel's approximation method, right? Okay, so and we're having the matrix minima method. So basically what we are having is in transportation problem, if I want to go from A point to B point, what is the best possible way so that I can optimize the resources and the cost related to that will be minimum. So basically what we're doing is, when we're having a specific supply demand pattern, the main objective is what will be the cost of transportation. That means what at minimum cost am I able to provide the we can say desired amount of demand is being supplied from the different workstations or factories to the different warehouses. Okay, the last one is the optimal assignment problem. That is also one of the special case. You might have heard about assignment problem or assignment LPP method. So these transportation and assignment, these are the two specific, or we can say special case of LPP, where we are discussing about how to allocate the different manpower to the different jobs. That is the assignment problem. That is also an example of LPP. So all these particular LPP or linear programming problem that we are seeing, we can solve by using two methodology. One is the graphical approach, and second one is a simplex approach. To solve any we can say LPP problem, we are having two basic methodology, graphical and simplex. Okay, fine. Is this clear till now? Any doubt you are having? Because step by step we'll be proceeding and we'll be taking one example. Now, for any LPP, for any linear programming problem, we already seen the transportation problem. Let's try to understand this transportation so as to have a better understanding. Let's say we're having factory in let us suppose in Delhi, we're having one factory in Chennai, and we are having one factory in Hyderabad. Okay, and the warehouses is in Goa, and the next warehouse is in, let us suppose, in Imphal. Okay, so these are the different warehouses. Now, to send one item from Delhi to Goa, will be having some, let's say, C1 cost. From Delhi to Imphal, will be having C2. From Chennai to Goa, let's say this is C3. From Chennai to Imphal, this is C4. From Hyderabad to Goa, that is C5, and from Hyderabad to Imphal, that is C6. We will be having some set of, let's say, 100 units need to supply. 100 units is the capacity of Delhi. Chennai is having a capacity of 250. Hyderabad is having a capacity of 300. Okay, and warehouses, let us suppose it is having a capacity of let's say 400. Okay, this is 4, and this is having a capacity of 250. And definitely demand and supply must be seen. Now, how much amount of item I need to send from Delhi to Goa, Delhi to Imphal, right? How much from Chennai to Goa and Imphal, and Hyderabad to Goa and Imphal? This particular there are any number of combinations. So which is the best possible combination so that my cost of transportation will be minimum? So that is basically the usage of linear programming problem. That is the main objective of using the LPP, where we are having the multiple solutions and the resources are limited. There we are using the concept of LPP. Okay, the same goes with the manufacturing problem and the diet problem, just like I already discussed with you. Now let us take one example to have a better understanding, like how we can solve a question from LPP. Okay, fine. Chali. So for writing any linear programming problem, there's a standard way to we can say represent. We'll be having one objective function. We'll be having one objective function. What is objective function? Objective function means which we need to optimize. The function which we need to optimize. Okay. And it is normally being denoted as capital Z, which is basically either we need to minimize the value or maximize the value. There are two possibility. Either I need to minimize the cost or I need to maximize the profit. That depends. By reading the question, we'll be able to understand. After that, we need to have some, we will be having some constraints or restrictions. We'll be having some constraints, right? Let's say A1x1 plus A2x2 till A1, A12, A1n xn is less than equal to 1. Let's say we are having A21x2, A22x2, A2nxn. So this way we can write as ANN xn, AN1x 1. This way we can write less than equal to, right? So these are basically, we can call it as the constraints. This is basically, we can call it as constraints. Constraints means the restrictions. Let us suppose you can have maximum of 100 gram of carbohydrates in a single meal. Let us suppose, I'm taking a rough example, and 50 gram of protein is required. Okay, 50 milligram of protein is required. So definitely we're having some upper limit, or we can say restrictions. So based on that, we will be formulating this constraints or restriction. Then the last condition for any LPP is the non-negativity criteria. That means all the variables that we are writing over here from x1, x2 till xn, this always should be greater than equal to 0. Okay, that means this is a non-negativity condition or criteria. Okay, that means no variable will be having a negative value. It always be a positive and a positive 0 or more than 0, right? Fine. So now let's try to take one problem to have a better understanding. And after reading the question, you will be able to have a better clarity how the question is being asked, what is this language they are using, and then we'll be solving this question, and from that problem itself I'll be taking one more example to understand some basic understanding. Okay, clear? Chali, so let's read out the question. One kind of cake requires 200 gram of flour and 25 gram of fat. So basically, let's say there's a cake A. We are having flour and we are having fat, right? So it requires 200 gram of flour and 25 gram of fat. And another cake requires, we are having another cake B. It requires 100 gram of flour and 50 gram of fat. What is the maximum number of cakes that can be made from 5 kg flour and 1 kg of fat? That means now we are having the limitation. I cannot have more than 5 kg or 5000 gram of flour and 1000 gram of fat. So this is the upper limit. Good evening. This is the upper limit. So this way we will be formulating a table. We will be formulating a table so that it's easy to frame this kind of equation. ठीक है, अब देखो क्वेश्चन क्या है, we need to maximize. This is a maximization problem. So it looks like this. We're having a cake A. This is cake A. This is cake B. And I've written all the values in gram. Okay. Now the question is how we can create the equation. Chali. Anyone? How we can, so they're asking how many maximum number of cakes that can be made from 5 kg flour and 1 kg of fat, assuming there are no shortages of other ingredients using making this. Now, basically total we can make how many cakes? Let us say I can make, let us suppose X, or we can write it like this. We can make A plus B. These are the total number of cakes that we can make and which we need to maximize. These are the total number of cakes that we can make. So basically we need to maximize it. 50. Okay. Yes. Any other? So let us suppose I am making X number of cake A and Y number of cake B. I'm making X number of cake A and Y number of cake B. So I can say X plus Y will be my objective function, or X1 plus X2 is my objective function. Yes, this is X1, this is X2. ठीक है, clear? अब question ये है कि how we can now if I'm making X1 cake, एक केक के लिए 200 ग्राम है, तो X1 केक के लिए will be having 200 X1. एक केक के लिए B cake we are making 100 gram is required for making one cake B. So if you are making X2 cake B, so we'll be having 100 X2. And what is the limiting value? What is the upper limit? We cannot have more than 5 kgs, so less than equal to 5000. So this is my constraint number 1. Let me rewrite over here. ये देखिए So we are having objective function which we need to maximize, that is equal to x1 plus x2, है ना, x1 plus x2. This is x1 और अच्छा they are using x and y ना, तो चलो x and y ही use करते हैं. They are writing it as x and y, so let us write x and y. ठीक है, यहाँ पे x for cake A and y for cake B. चलिए try to solve it. Try to solve it quickly. यहाँ पर भी x और y कर देते हैं. Okay, it won't have any changes. ऐसा नहीं है कि x की जगह if you're using x and y or x1 or x2 will be having different set of values. No, we'll be having same result. Only or in representation is changing. Okay, chali. Fine. So this is my first equation will be 200x plus 100y is less than equal to 5000. This is the constraints for the floor. Second constraint will be 25x plus 50y less than equal to 1000, and this is for fat. So these are, we can call it as constraint. These are called as constraints. Is this clear? इसको बोलेंगे constraints. The same thing which we have written over here. देखो, we had an objective function. We are having the constraints. We are having the constraints, and one will be definitely x and y will always be greater than equal to 0. We cannot have x and y to be negative. ऐसा थोड़ी ना होगा कि that I'll be making a minus 10 cake today. Always will be having either 0 or more than 0. Clear? All right. Understood? Any doubt? So now, can we solve this question now? Let me rewrite this equation over here. We're having objective function which we need to maximize, that is x plus y, and we're having the objective function as 200x plus 100y less than equal to 5000, and 25x plus 50y less than equal to कितना है 1000. चलो, so whenever we are having this kind of equation, we need to create into the intercept format. Intercept format मतलब x by a plus y by b. So if I try to divide by 5000, we'll be having x divided by 4 plus y divided by 1 to 50. है ना? Please check. अगर मैं divide ना 4 नहीं 25. Yes. 5000 divided by 200, 1, 2, 25, and this is 1, 2, 50, less than equal to 1. This is constraint number 1. So constraint number 1, this is the constraint number 1. Constraint number 2 will be divided by this. So we'll be having x divided by 4 plus y divided by 40 divided, this will be 20. Please check. क्या यही आ रहा है constraint number 2? If you divide by this one, this is 40 and this is 120. हाँ, perfect. ठीक है? Any doubt? All clear? So now let us try to plot the graph. अब हमें ग्राफ क्योंकि देखो this is linear inequalities. So whenever you are plotting the graph for linear inequality, you have to see whether we are having less than equal to or greater than equal to. Remember one thing, जब भी whenever we are solving question for maximization problem, you try to convert this into less than equal to for easiness. अगर नहीं है तो कोई दिक्कत नहीं है. But we always try. And one more thing, always remember that the right hand side should always be a positive value. ऐसा नहीं होना चाहिए the right hand side is a negative. If it is negative, then we have to interchange the your inequality signs. Less than equal to will become greater than equal to, or greater than equal to becomes less than equal to. Okay, chali. So let's try to plot this on a graph and let us try to understand what will be the optimal solution for this. This is x, this is y. The पहला equation क्या है? 25, 50. And this is a rough graph. ऐसा नहीं है कि I have to go for a perfect graph. So let's say this is 25 and this is 50. So we'll be drawing a straight line passing through these two. And they are saying that all the values less than equal to 1. That means we have to take all the values towards the origin. So this is constraint number 1. Always write the number of constraint number on the arrow. क्योंकि देखो यहाँ तो 2 ही है, so won't be having an issue. Sometimes we are having 3 to 4 number of constraints. तो वहां पे it becomes difficult to identify which constraint कौन सा line है. ठीक है, fine. चलिए, next constraint we are having 40, 20. Let's say this is 40 and here we are having 20. ठीक है, so it will be something like this. All right, constraint number 2. Now we have to see the region which is being satisfied by both the condition. दोनों condition को satisfy करने वाला region. So definitely if I try to see the arrows, both are pointing towards downward. So the feasible region will be somewhere around here. The shaded portion, this is the feasible region. If I try to identify the corner points, let's say this is A, this is B, this is C, this is D. So according to corner theorem rule or corner rule, the optimal value will always be located at the corner of this graph. Clear? Yes. One second guys, one second. जो optimal value होगा, that will always be located at the corner point of this graph. Clear? So first of all, tell me what are the coordinates of point A, B, C and D. देखो A तो origin है, we are having A as origin, that will be having 0, 0. Let's start with D. D is having coordinate over here, so on the x-axis that will be 25, 0. If I try to take B, that is a coordinate having 0, 20, right? What is the coordinate of point C? Now C is an intersection of these two lines. Equation क्या है? Equation is this one, है ना? आपका equation है, so we can write the above equation. One second guys. Perfect. Now yes, any doubt you're having, please do let me know. All clear? ऑडियो एंड वीडियो पे कोई दिक्कत तो नहीं है ना? एंड प्लीज डू लाइक द सेशन गाइस, दैट इज आल्सो वेरी इंपॉर्टेंट पॉइंट. हाँ, 20 and 25, perfect. That means point. Now we can write this equation as we can say 2x, first equation 2x plus y is equal to 50. Second equation can be written as x plus 2y is equal to 40, right? Now if I try to multiply 2 over this, ठीक है, and subtract कर देते हैं, so it will be having 4, that is 4 minus 1 minus 3y, 80 minus 5 30. Okay, fine, one second. So y is equal to minus minus नहीं 10 आ रहा है, please check. If y is equal to 10, then x will be equal to 20. Place it. If y is equal to 10, then x equal to 20. All clear? हाँ, बहुत बढ़िया. बीच में I think there is some issues going on. परचेज करना है, अरे वो देखना पड़ेगा, मैं आपको डेट बता दूंगा, डोंट वरी. ठीक है, whenever it will be coming ना, मैं आपको डेट बता दूंगा. ऑलराइट, चलिए. सो वी आर हैविंग द कोऑर्डिनेट एज 20, 10. 20, 10 ये वाला 20, 10. ठीक है, एक बार चेक कर लीजिए. 20, 10 40 प्लस 50 प्लस 20 40. ठीक है. सो ऑब्जेक्टिव फंक्शन क्या था? z इज इक्वल टू x प्लस वाई. सो ZA will be equal to 0. Place x and y value. ZB will be equal to 25. ZC will be equal to 20. ZD will be equal to 20 plus 10, that is equal to 30. So the maximum value we are getting at point C. This is the maximum value. So our final answer is 30. है ना? Our final answer is 30. Clear है? सेकंड, पता नहीं क्या हो रहा है. हाँ, the final answer is 30. Understood? हाँ, very good. So we can say the maximum number of cakes, the maximum number of cakes that can be manufactured will be 30 cakes. 30 cakes. ठीक है, 30 cakes आपके यहाँ पे बनेंगे. Clear? Very good. Fine. Whenever it will be available, na test series might be date तो पता नहीं है, but because we are working very hard to make the test series available as soon as possible, तो make हो सकता है by next month, max to max we are trying कि इसी month हो जाए, मतलब जून महीने में ही. So by June end we are planning कि आपको दे दें, right? I'm not sure about the month. So maximum we are trying day every day, not even we are not having any Sundays, right? क्योंकि now we are only need to look for the classes के बाद we need to see for the management type कि भाई questions are being of that level, classes are happening at on time. Previously we had a complete team, now we are only the team. तो इसीलिए we want a quality questions, we want the quality content. For that only we are taking some additional time ताकि आपका preparation optimal हो. Okay, so the answer for this is 30, right? So this is about the graphical approach. This is all about the graphical approach, right? Now इसमें कभी कभार there are some question that is being asked और कुछ conditions होते हैं that we need to understand. देखिए, let us suppose I'm taking, now you might have understood how to get the answer. Now let us suppose I'm having a solution like this. Let's say this is constraint number 1, this is constraint number 2, and you guys gonna tell me, आप बताएंगे, आप लोग बताएंगे, this is constraint 1, this is constraint number 2, ठीक है, and we are having this as constraint number 3. So tell me which constraint, because the feasible region will be this one, which constraint, if you are even removing that constraint, the final answer, the final feasible region, this is the feasible region, the feasible region is not gonna change. बता सकते हैं? There are 3 constraints, मैंने plot करके दिखा दिया, 1, 2 and 3. Can you tell me which of the following constraint will be giving, or even if you are removing that constraint, my feasible region is not gonna change? 1, 2 और 3 में से बताइए. Yes, 1, 2 और 3 में से which constraint? अगर आप देखेंगे, if I try to remove constraint number 3, let us suppose by any reason I am removing this, क्या मेरा feasible region में कोई change आएगा? There is no change in the feasible region. So that kind of constraint, which is, even if you are removing that constraint, my feasible region is not changing, इस type के constraint को क्या बोलते हैं? Redundant constraint. Redundant constraint. ठीक है, INT. This type of constraint we call it as redundant constraint. Perfect है. Okay. अब there are some special cases. अरे PPT का खत्म हो गया. अच्छा, there are some special cases. एक मिनट ना guys. Let me add one blank PPT. First, it will be required. कहाँ है blank PPT? One second. Yeah. Now, if I try to tell some special cases, so the first special solution, special case is your infinite multiple solutions. What is the meaning of this? Infinite multiple solutions means, let us suppose we are having some feasible region like this. We are having some feasible region like this. Let's say this is X, this is Y. ये आपका constraint 1 है, ये constraint 2 है, something like this. ठीक है, let's say this is the feasible region, and we are having the corner points as A, B, C and D. ठीक है, these are the corner points. Now let us suppose you calculated ZA value, that will be 0 क्योंकि origin है. मैंने ZB value निकाला, let's say this is, you are getting 30, ZC निकाला, that is equal to 20, and we are calculating the maximum value, and again ZD, it is coming out to be 30. Now it is being seen that by maximum value I am getting at two different points, है ना, maximum value maximization problem है. So I am getting the maximum value at two different points. So these kind of solution where you are getting the optimal values at more than one solution, this kind of solution we call it as infinite multiple solution or alternate solutions like this. Clear? Previously the example that we have taken, this is an example of a unique solution because we are getting a single value, a single solution. Understood? Clear? This is we can call it as an infinite or multiple solutions because we are getting more than one point at which the optimal solution is being present. Understood? Clear hai? Yes. Chalo, let's go with the second category. No solution. Entire graphical I am completing in YouTube. अब मैं entire graphical का पूरा lecture I am discussing over here. ठीक है? No solution. How we can obtain a no solution? No solution means there is no feasible region. कुछ इस तरीके का केस है, केस like this. X, Y, we are having, let us suppose one constraint like this and second constraint, let us suppose something like this, and it is greater than equal to. So here you can clearly see there is no feasible region. Use a different color. There is no feasible region. That means what's the meaning of this is there will not be any optimal solution. इस type के problem में there is no solution possible. So that is the reason we can call it as no solution. Okay, clear? Understood? चलो, third category, unbounded solution. Unbounded solution. What is unbounded solution? Where the boundaries are not defined. We are not having a closed boundary, something like this. Let us suppose I am having this as x axis, this as y axis, और हमारे पास इस तरीके का constraint है. जैसे this is constraint number 1 and this is constraint number 2 and this is constraint number 2. And both are like away from origin. So if I try to identify the feasible region क्या होगा? This will be the feasible region. This will be the feasible region. So here the region is unbounded. We are having an unbounded feasible region. So in this case, if I'm getting an optimal solution, because this will be the corner points, ये 3A, B and C, these are three other corner points, and at these three corner points, and usually this is a question from the minimization problem, वहाँ पे हम Z minimum निकाल रहे हैं. So usually we can expect an unbounded solution only in case of minimization problem. Maximization में maximum unbounded है, तो that will be infinity, that is not defined. Clear है? Understood? Done? Special cases in linear programming problem, the graphical method we have seen in detail. Clear hai? Done? No doubt. And this is very easy. The graphical method we can only use. Now let me tell you some limitation. Graphical approach is only applicable when you are dealing with only two variables. अगर 3 variable हो गया, let's say x, y and z, you cannot plot a graph. मान लीजिए you are having x, y and z. How you can plot a graph on a piece of paper? It is not possible. That will be a 3D curve. And plotting a 3D curve on a piece of page, बहुत difficult. Okay? Fine. So remember one thing, graphical approach is only applicable whenever we are dealing with two variables only, x or y or x1 or x2 like this. Okay, done. Fine, perfect. So tomorrow we will be having a discussion of very important, very important, that is simplex method. Simplex method, entire discussion will be done on simplest method tomorrow at 7 PM. तो देखना ना भूलिए, कल मिलते हैं. Simplest method नाम simplex है, that means it looks like simple. It is a simple method but slightly lengthy. ठीक है. So usually simplex method is being asked in mains level examination, but gate maybe I have seen that they are asked question from simplex by giving some intermediate values, because simplex method is an iterative process. One iteration, second iteration, third iteration, चार पांच iterations के बाद we are getting a final solution. Okay, so tomorrow we'll be taking one example on simplex method, and we'll be dealing that by solving that question we'll be able to understand how to get the understanding of simplex method. Okay, so that's it from my side. I hope you all enjoyed the session. So thank you for joining with us on Resultant, and I request you to be connected with us, because let us suppose if you are not subscribing to this channel, so what will happen whenever some notification, exam notification is coming, या कुछ भी आता है, you won't be able to get that notification. ठीक है, तो it's for your benefit only I'm saying, do subscribe to this channel and do share this video to all of your friends. Okay, so thank you guys, bye bye, take care, stay safe, and enjoy your preparation journey with Resultant. Thank you, bye bye, take care.